these problems, then you can do number 2 and number 3. The answers are here. And again, it's not a big deal if you know the answers in advance because you're going to solve them a different way. This is going to be your benchmark. You're going to know, did I do it right or did I make a mistake? It's going to save you time in the long run. If you know that you made a mistake, you can start to try to scroll through and find it. So today, we're going to complete the square still, but for a different reason. Right? Sometimes you complete the square to not just solve an equation, but to rewrite a quadratic equation. So here we have the standard form of a quadratic. Y equals ax squared plus bx plus c. That's the standard form of a quadratic function. When we spend time graphing, we graphed in that format. And what were we able to identify when we had a quadratic in that format? When we were graphing. Oh, okay. How? No, I'm not talking about an equation. We're talking about a function right now. So if I was to graph this, what can I do in this format? What were the things that I was able to easily identify? The y-intercept. Yeah, the y-intercept is what value? The c value, absolutely. What else could I identify just by looking at it in this format? Sort of. Not necessarily the way that it increases, but what about it? Yeah, like if it goes up or down. Good. What could I find, but with a calculation? Okay, so I could solve and get the x-intercept. What else could I find with a calculation? Yeah, we could find the axis of symmetry, and then if I found the axis of symmetry, what could I find? The vertex. Good. So today, we're going to look at a different format for our quadratic. So this whole page will be written. I'm going to go through and break down the entire thing. Okay, so this is still a quadratic, but it's written in a different way. This is called vertex form. And the reason it's called vertex form, pay really close attention to the color. I hate that they keep using different variables, but the h and the k just represent a number right now. Any number. Okay. So instead of that ax squared plus bx plus c, which tells us our y-intercept and if our parabola is going up or down, we could see a quadratic in a different format. This format called vertex form is y equals x minus a number squared plus another number. And if you see a quadratic in this format, you could pull out the vertex just by looking at the numbers in the equation. The examples below are going to help you in probably the best way. If you have a quadratic and it's written in this way, y equals x minus 4 squared plus 3. The vertex is positive 4 and positive 3. Notice where these numbers are coming from. If you had a quadratic written as y equals x plus 6 squared minus 2, the vertex is negative 6 and negative 2. What do you notice we are doing to that h value to get the x value of our vertex? Like because in the equation it's a negative 4, but our vertex has a positive 4x. And then in the other one it's a positive 6, and in our vertex it's a negative 6. Yeah, the sign is alternated. Okay, but then the second value is the same. So there might be times where you're asked to put a quadratic into vertex form, like that. So going from that standard form to vertex form. Now you could calculate the vertex if you have a quadratic in standard form, but it's a little bit of a process, right? Remember, it's like negative b over 2a, and when we calculate that, we get our axis of symmetry. We take our axis of symmetry, we substitute it in to get the y value, time consuming. Or you could just have your equation in that format, look at the numbers, your vertex is 4, 3. Your vertex is negative 6, negative 2. The way that we put an equation into vertex form is by completing the square. So that's what we're going to focus on today. Does everyone have this written, or are we still writing? So we can complete the square to actually find the vertex and rewrite our equation. So we're going to find the vertex of this equation by completing the square. So first thing, is that a perfect square trinomial? No, so I'm not going to be able to write it like as this product of two binomials, right? Because it's not in that format yet. So I'm going to do that. I'm going to actually complete the square. If I had this equation, how would I complete the square? Yeah, I want to get rid of the 8 first because I'm going to complete the square and add in another c value. What am I going to do on the other side? I'm going to subtract an 8. So what will the left side of my equation become? Say it again, Melanie. Y minus 8. There's a y there. Right, don't forget this. There's a y there because this is a function right now. Y minus 8, good, equals x squared plus 6x. Good. Now what? How do I complete my square? Yeah, I'm going to do that 6 value divided by 2, and then I'm going to square it, which is 9. What am I going to do with that 9? I'm going to add it to both sides. That's key. I'm not just adding it here. I'm also adding it here. So what's the left side of my equation now? Y plus 1. And I could rewrite the other side of my equation now. I could rewrite it as that binomial squared. What is the binomial squared? X plus 3. And looking at your notes, because I know you have an example of a quadratic in vertex form, what's the last thing that I would want to do to put this in vertex form? Oh. Look at your examples of vertex form. Subtract what? Subtract the 1. So we have an equation, same equation, I didn't change the value in any way. What's the vertex? Negative 3, negative 1. Because when it's in this format, I just need to look. I don't need to calculate to find my vertex. My vertex here would be the opposite of that number, which would be negative 3, and that number as it stands, which is negative 1.
Oh, okay. It's a negative 3 because you multiply a negative 1 times the.
So I'm going to show this to you on the next slide. Typed out. It's the same thing. Any of the work I just did is there. Don't worry. This is just typed out to kind of show you where it came from. Again, we have this quadratic y equals x squared plus 6x plus 8. We can complete the square to put this into vertex form, subtracting the 8 from both sides. Completing the square with my formula, b divided by 2 squared. Whatever value I add, I make sure I add it to both sides to keep my equation balanced. Once I have this perfect square trinomial, I can rewrite it as the product of two binomials, more specifically, the binomial times itself, which is this x plus 3 squared. And the last thing I would do to put it in vertex form is take away the 1. I can identify my vertex at this point, negative 3, and a negative 1. I'm just going to pause if people are still writing. Now that's one way you can find your vertex. If we kept it in standard form, you would have been able to calculate your vertex. That really wasn't overly calculation heavy. What I mean is we weren't finding the square root. We didn't have to substitute values in. we just removed a value, did a one quick little formula, and then moved a value back, and we were able to find our vertex immediately. If we know our vertex, we also know our axis of symmetry. Now, if we kept it in this format, if we kept it in this format, how would I have found the vertex? If I kept it like this, what would I do to find my vertex? To find the vertex, I would need to know the axis of symmetry first. If I kept it like this, how would I have found the axis of symmetry? Check it. Check your calculation. Check it. All right, negative b over 2a, which is what here? Negative 6 over 2 times 1, and that equals negative 3. That's our axis of symmetry, which, if we were going to find our vertex, is the first value. How would I have continued on to find my vertex now? I would have substituted the negative 3 into my equation. Negative 3 squared is 9. 6 times negative 3 is negative 18. Plus 8 equals negative 1. So not only did we prove that when we wrote it in vertex form, our vertex was correct, but we also kind of showed that it depends on your strength. If you are asked to just find the vertex, it might end up being faster and more efficient for you to put your equation in vertex form. Completing the square only requires subtracting that value, finding the new value, and then moving the value back. Here, you have to do a formula, and then you take this value, and then you substitute it in, and then you have to calculate. Maybe more room for error, maybe not. There might be specific questions, and I'm really referencing the park on this one, where they expect you to rewrite a quadratic in vertex form. Right? But there also might be times where you may want to rewrite an equation in vertex form. So we're going to try this one together, and then you're going to do one on your own, and then we're going to practice. If I were to write this quadratic, and well, rewrite, I should say, in vertex form, where would I begin? Oh, good. I can subtract 10 from both sides. So we have y minus 10 equals x squared plus 4x. Someone give me our next step.
The b divided by 2.
What am I trying to find now? I want to find my new c value, the value that I'm going to add in here that's going to complete my square. What is the value that would make this a perfect square trinomial? 4. Over time, you might not always need to spend time saying b divided by 2 squared. As you get more comfortable with what makes a perfect square trinomial, you might start to do that naturally. If I add 4 to the right side of my equation, what else must I do? I must add 4 to the other side. So my equation becomes y minus 6 equals what? Yeah, I could rewrite it at this point if I wanted. If you wanted to write out the trinomial before factoring it, you could. What's the last thing I would do to put it in vertex form? Add 6. So we have y equals x plus 2 squared plus 6. What's my vertex? Negative 2, positive 6. Take a look at what we did. Try and find a spot where you are getting stuck, or maybe you're not sure where the value came from. Because now would be the time for us to break down that answer, so that on the next slide, when you do one on your own, you can use whatever you have in reference. Is there any level of this that we need to go back and address? Do we see how we're taking that trinomial and we're rewriting it in vertex form?
How did you do the thing with the x plus 2? Like, how did you get that?
This?
Yeah.
It's a good question. This is probably the most different transition from one level to the next. So this perfect square trinomial can be rewritten because since this is a perfect square trinomial, that means it's actually factored out to be x plus 2 times x plus 2. So I can write that as the binomial x plus 2 squared. Okay, so that's really, I kind of skipped a level there as I wrote that out. Any other part of that we want to go over before we try one on our own? Now, I overheard a few students earlier saying like, wow, this just becomes, I noticed a pattern, it becomes really repetitive. That's not incorrect. This process is the same no matter what the numbers are. When we get back from the break, the only addition we would have to putting a quadratic in vertex form is if the coefficient of the x squared is greater than 1 or a different number. There's a couple hanging around the room, which we're not going to do today. But I'll show you at the end of class what that looks like, so that you're not blindsided when we come back on Monday, April 9th, and jump right back to this. We have to go right back to this so we don't lose time. So you're going to try one on your own. Okay. I'm going to pause the video as you're working on this. I'll post this to the Google Classroom right after school if you need to go back over it. And these are things that are so brand new, like today and yesterday, that these are worth going back over the break and spending a little bit of time. Okay, so this one I want you to try on your own. X squared plus 12x plus 34. Using every part of the examples that you have in your notebook, put that into vertex form by completing the square.